And this morning I'd like to welcome, and it's this evening for this particular speaker, Professor Ed Cozier from Australia. I first met Ed about 4 or 5 years ago. He'll probably correct me on that. But it was because he was leading an innovative project into plastic sustainability. So he is spot on for this conference. He's also got a lot of experience in the field. He's been an academic from the Royal Melbourne Institute of Technology, where he's taught and done research on polymers and plastics. And he's also run some successful businesses across the world as well. So he's ideally placed to talk about all of the issues that we've got here today. So I asked Ed what he thought the future would look like for polymers. So Ed, if you can give us your thoughts, that would be fantastic. Thank you.
Thank you, Sally. Thank you for that kind introduction to this talk. And the conference is fantastic. I greatly enjoy the sessions I could join in on. My talk is about what does the future look like for polymers, and my comments will be primarily on polymers used in packaging. Can I have the next slide, please? And just a few words about Nextech. Nextech's been operating for about 17 years, working exclusively on the recycling of post-consumer plastics. We design recycling plants. We also support companies that need assistance in creating circular products with recycled content into their materials. We also get involved in areas of new material development as well. Next slide, please. So today I'm going to be looking at first of all, where we are heading and what we may have to change. Right now, if we stay with business as usual, here are some of the things that will be happening. We are on the way to a zero net carbon future, hopefully, globally. And the target is generally set at 2050. However, by 2030, we will have reached 1.5 degrees increase over the pre-industrial revolution levels of temperature. So we are on the edge of the tipping point, which basically means our carbon future has to be firmly grasped and changed. The level of CO2 in the atmosphere right now is over 400 parts per million. It's 418 parts per million in March. By 2040, plastic production will be 400 million tonnes per annum. Just think about that, 400 million tonnes per annum. That's every year. And it will be 20% of oil production. At the same time, in 2040, we'll have a population of 9.2 billion people to feed. And right now, we typically waste 35% of the food that's grown on this planet. And yet we know plastics are a key way of minimizing food wastage, especially for the populations that are going to be living in urban centers. People in India, people in China that are moving to big cities are not growing their food, but it needs to be brought in. So plastics are a key part of that. And of course, for every ton of plastics we recycle, we can potentially save between 1 and 1.5 tons of carbon. So a future where we do something with plastics is still quite important. And of course, if we're going to address our carbon targets, recycling is also equally important. We have 35,500 species on the extinction list right now. We generate 11.2 billion tons of solid waste right now. This is in this year. And of course, if we project our use of plastics and our leakage to oceans, based on where we are now, by 2040, it will be 29 million tons per annum. These points all indicate that we need very significant and systemic change. Next slide, please. So what will society do in the next 5 years? Because I think we can all understand what might happen in the 5 years. Well, the European Commission have made it very easy for us because they've mapped out the European Green Deal on the pathway to climate neutrality by 2050. And there are some special implications for plastics here as well. The EU is spending over 100 billion euros by 2027. And this year, in July, they'll be phasing out specific single-use plastics. There'll be labels that'll have to go onto products indicating that they contain plastics, which will indicate that they'll be treated in a special way. And they'll be targeting the reduction of the waste that we generate, and they'll be reducing the exports of waste, including plastics waste, which will mean we'll have to deal with the plastics we use within our own borders. And the focus will be on packaging circularity and recycling and carbon footprint reduction and durability in products. So we're going to be ending the discard era that we've been living in. No longer will we be looking at that. We'll be looking at reduction of all the things that we know are wasteful. And of course, the targets for recycling are already well known, 50% by 2025 and 55% by 2030. And just to encourage everybody along the way, there'll be taxes to boost the demand for recycled material. And we know that these implications will start to drive things hopefully in the right direction. On the right-hand side of the slide, we've got some savings that are expected from the ban on single-use plastics, and they are in the areas of litter reductions, climate gas reductions, environmental damage prevention, and then savings to consumers because we'll be making less and spending less on single-use plastics. Next slide, please. So these are things that are going to happen in the next few years. But what sort of changes do we need to implement long-term? Well, the Pew Foundation Trust, in looking at how they can address the issue of reducing plastics going to oceans, have actually mapped out a whole series of changes. And they include the reduction in the amount of plastics that's made. They're postulating that we should be making 30% less than we expect at that time. And there'll be substitution for plastics by other materials, including plastics and paper and compostable materials. And we'll be designing products and packaging to be recycled. And that should boost the amount of recyclable plastic from an estimated 21% to over 54%. These are all pretty important changes to make. And of course, one of the big areas where there has to be activity is expanding the collection of wastes in middle to low income countries, especially from the urban areas where currently they are responsible for a lot of the materials that escape into the environment. They also predict and suggest that we double the mechanical recycling capacity globally to 86 million metric tons per year. Now that's a big increase to account for, especially by 2040. And they also postulate that we should be developing chemical recycling technologies so that we can actually take materials that we currently find difficult to recycle and recycle the carbon back into carbon-based materials like the plastics that we would need to use. And they're predicting 13 million tons by that year. And yet we will still need to build facilities to dispose of up to 23% of the plastics that can't be recycled. And so these things are all important changes that we would need to implement. And of course, one of the last things on that list are to handle plastics where we make them and use them, and to reduce exports. And so I'm going to come back to this point to look at what sort of implications there are at the very end. And the other rider on all these systemic changes is, besides the targets, we also need to make sure that there's no negative carbon impact, and they need to be all LCA checked. Next slide, please. So what are the implications? And they come back to the way we design and manufacture products. Most of the impacts of plastics packaging are created at the design stage. So we really need to think carefully about how we design. Much of the plastics we make is pigmented, but they could, in many cases, be unpigmented. This actually greatly boosts the recyclability of those materials. And in a humble product like a milk jug and also drink bottles, we have caps of many colors and also in some cases of a number of materials. And ideally, we should do something about the color and the fugitive nature of these caps. And the same with labels and inks and adhesives. They all need to be recycling compatible. Right now, many everyday products are made without real thought about the next generation of recycling. And we should all think that every product that's made should be capable of going back into its existing product. Next slide, please. So here's some of the things that really need attention. And the European Union has said by June 2024, all caps will have to be tethered so that they won't be able to be lost from their container, and they'll go with them all the way through to the recycling centre. And there's been a lot of controversy about this, but it's such a simple and important thing to do. Next slide, please. We need to evolve our design for closed-loop recycling. And there are already very good examples that this is actually not that difficult, and it could be implemented right now and quite widely. I've got two examples of bottles where they are made very simply with minimal labeling, labels that come off very easily, caps that are unpigmented, and in one case, a bottle with no label with the engraving on the bottle. These are all very simple things, and if we follow these guidelines, we can actually achieve much higher recycling rates. In Japan, every bottle is clear in PET, and the recycling rate of bottles is something like 89%, and they're heading for, they want to go for 100% by 2030. So it shows that these things aren't too far away. We just need the resolve to go there. Next slide, please. Going away from bottles, going to pots, tubs and trays. Many of these products have been pigmented, decorated in lots of ways, and even though they are tagged as being recyclable, they in general haven't been thought of as being recycled, and with no thought of what they'll be recycled into. And so things like the pigmentation systems, could all of these materials be pigmented or unpigmented so they'll be clear and with some other form of decoration that's easily separable and that doesn't interfere with the next loop of recycling? Hopefully food grade products would go back into food grade and create the biggest value for these materials. Next slide, please. The way we start to recycle is with collection. Collection is key, both in developed countries and developing countries. Without collection, we can't even start to tackle the issues of plastics escaping to the environment. Indeed, we need to collect in order to stop the worst impacts. So collection has to be very comprehensive. It has to be simple and easy. It must be uniform across countries. And of course, as we've mentioned earlier, it has to be developed in countries without these regular collection systems. All packaging has to be recyclable. And it's a simple statement to make, but it's surprising when you look at packaging on the market now, much of it is made with no real focus on its recyclability. And so we need to truly focus on this. And the major polymers that are being used are PET, high density polyethylene, polypropylene, and the low density polyethylenes. Other polymers outside of this are going to find it difficult to join the ranks of economically recycled materials. Although polystyrene is making a key resurgence now with some very new technology making it recycled back to food grade. And of course, PLA is quite interesting because it's bio-based, but as you can see in the diagram or in the image there, there's a PLA and PET container side by side. Well, which is which? And they're not miscible, not recyclable together, and we don't have in general an end destination for PLA containers. So this collection is key, and it has to be streamlined so that we know what we're collecting and collecting it, able to collect it in volumes and recycling it. Thank you. Next slide. One of the big innovations that will happen in the near future will be our capacity to sort beyond just recognizing that materials are made of a specific polymer. for food grade recycling, and of course this is one of the big areas for the use of plastics, we actually need to know that the product that we're putting into the recycling process was a food grade material and used for food in the past. So this is the big priority for sorting in the future. And now we've got technologies like digital watermarks, fluorescent markers, and other emerging sorting technologies that we will eventually evolve to very big commercial activities to give us that capacity so we can separate food from non-food. And of course, there are some products that come out of the garage and the garden shed which contain toxic materials, and we need to be able to identify and separate them out, not just based on polymer, but based on what was in them. And I know I've got here, our fourth priority should be difficult to recycle packaging. Well, in the near future, those difficult to recycle packages should not exist because we shouldn't be making them. But maybe there's a category for them as well. Next slide. And in the area of recycling technologies, we're very lucky. We've got many robust technologies for PET, polyethylenes and polypropylenes, but new technologies need to be developed and indeed are on the cusp of being commercialized. One that catches my eye is the pure cycle technologies, where they are dissolving polypropylene to take out fillers, pigments, additives, and end up with a material that looks like a clear virgin material. That's something that we'll all be watching with interest. Now, are there parallels for all the other polymers? Not just yet. Next slide. In some work that we've been looking at, we've been focusing on how do we take the polyolefins and turn them back into food grade materials. PET is widely recycled back to food grade, but the polyolefins are not. And so this has to be the next area of endeavour. And in a recent feasibility study where we've looked at the use of supercritical fluids, we were able to decontaminate the three major film forming materials, low density, polypropylene and high density, back to very low levels of contamination. So our tests show that we could remove surrogate contaminants that were added at high levels as a test to levels of 100% down to 98.3%. So hopefully these technologies would allow us to make food grade polyolefin materials in an efficient and effective way. Next slide. Just in the area of closing the loop on plastics, which is what we're proposing for the future, this has to be a big part of what we do. And here there will be lots of changes needed by brand owners and what they expect consumers to accept. If you have a look at the images on the slide, there are 4 pairs of bottles. One of them contains recycled material and the other doesn't. The brand owners want the colours all to be the same and to have no variation. However, there will be variation if we use recycled material. And so somewhere along the line, brand owners need to make their minds up about the way they decorate and what variation is acceptable. And of course, maybe they'll start leaving out pigments altogether and use another form of labelling. Next slide. One way that we could actually incorporate coloured materials and recycled content together is actually to make the packaging, and here we have some trigger packs, from mixed recycled materials. They end up turning out to be grey, but once we put a shrink sleeve on the outside, they look exactly like the original product, which actually is made white, but the sleeve contains all the marketing and detailed consumer information that everyone would need. And of course, underneath there is a grey bottle. Is this a new way of going? Is this potentially a signature for brand owners that they are using recycled content? And of course, this is something that has to be adopted in a big way, and it certainly would expand the scope for packaging like this, which is in this case non-food. Next slide, please. So this is my last slide, and I'm going to just quickly go through what sort of things we could change if we actually implemented some of the factors that we mentioned earlier. The costs to government and business would go down compared to the first slide. we'd generate more jobs in recycling. The emissions that we would be emitting would be reduced because we would be recycling more, and the volume of virgin plastics could be reduced as well. Now, in the expansion that Pew Trust looked at, they were saying that there would still be emissions of 5 million metric tons of plastics going to the oceans, even after all of these implementations were put in place. And that means that we actually have to try even harder than what we may have to do with all of those interventions. So my message for everyone is plastics will still be an important part of the future. They'll be a key part in reducing carbon emissions. But producers are going to have to do much more with the design, with recycling and recycling content. And of course, along the way, we're going to discover new technologies and better ways of doing this. As I always like to finish, none of this is rocket science. We can do it tomorrow. Let's get started. Thank you.